Light is 225 kilometers above the Earth's surface. Given the mass is of the Earth is 5.97 times 10 to the 24th kilograms, and the radius of the Earth is 6.38 times 10 to the 6 meters. Find the satellite speed and period. So let me give you a visual representation of that. So the Earth is the source, and here's our satellite. It's orbiting the Earth like this. Remember that. Remember, Earth is pulling the satellite towards it, but just at its certain sweet spot. Too much, and it'll be sucked towards the Earth. Too little, and the satellite will be flung in space. But yeah, it's this is what's keeping it in orbit, the centripetal force. And remember, the distance is the distance between the center of the Earth and the center of the satellite. So we know the center of the Earth to the Earth's surface is 5.97 times. Wait, no. That's the that is mass. You know that the radius is 6.38 times 10 to the 6 meters. But the satellite is 225 kilometers above its surface, so we would have to add 225 100,000 meters because there are 1,000 kilometers in a. I mean, there's 1,000 meters in a kilometer, so I just multiplied by 1,000. And this is our R value that we can use. So because the force of gravity is the centripetal force, we can use mv squared ms over r equals g times me over ms. Me is the mass of the Earth, and ms is the mass of the satellite over r squared. Remember, don't forget to add these. So the mass of the satellite cancels out, which means that it's mass independent. Say if you have a satellite that is 1,000 kilograms versus 100,000 kilograms, it would still move at the same speed because, as you see, the mass cancels out. So v squared over r equals g me r squared, and then multiply r on both sides. V squared equals g mass of the Earth over r, and then v equals the square root of g mass of the Earth over r, which is about 7.764 meters per second. And we also have to find the period as well. So we're going to use the formula velocity equals 2 pi r over t. And then basically what we're going to do is solve for t. So I'm just going to flip both sides. divided, and so I'll do 1 over v and 1 over 2 pi r over t. So I get 1 over v equals t over 2 pi r, and then you get that t equals 2 pi r over v, which is roughly 5,344 seconds. So here you go. Alright, so this next part, we basically have the sun, the moon, and the earth. So the moon is 1.5 times 10 to the 8th kilometers away from that. I mean, that's the distance between the sun and the moon. And the distance between the moon and the earth is 3.9 times 10 to the 5th kilometers wide. So what we're trying to find is the force of gravity, the ratio between the force of gravity of the earth on the moon over the force of gravity of the sun on the moon. So basically we're just trying to divide Fg E on M over Fg S on M. So let me just rewrite that as G M E M M over R squared over G M S M M over R squared. And let's call this R1 and then R2 because they have different distances. So we see that the mass of the moon cancels out, and I'm gonna right here, and then I'm gonna rewrite this as, and also the gravitational constant cancels out. So I'm gonna rewrite this as ME times R1 squared over times R2 squared over MS, and that is the answer. And then when you plug in everything, you should get around a ratio of 0.44. Alright, so next we have another problem here. So planet X, the largest planet in some solar system, rotates around its own axis in 10.28 hours, and the diameter of the planet is 1.84 times 10 to the 8th meters. So find the angular and linear speed, and for the linear speed you have to find it at the equator. So if we recall from that little review, angular speed is 2 pi over the period. And because velocity equals angular speed times r, velocity is 2 pi r over t. So, and also we have to, since it's in hours, we have to convert to seconds. So 10.28 hours times 1 hour, and then 1 hour is 3600 seconds, and then that'll give you your period. So when you plug that into angular speed, that will give you about 0.00001 radians per second. And because angular speed is, linear speed is angular velocity times radius, we can just take this answer and multiply it by r. But the thing is, they give us the diameter. So what we can do is we can actually simplify this and divide by 2. Or if you want to use this equation, you can just say V equals pi times diameter over r. But when you do that, you get an answer of 15,000. Hold up. 15,619.7 meters per second.